is number 14. So they did it using the perfect square method. I'll talk through that. If you want to see the other one, let me know. Your final answer should have been negative 8 times the square root of 3 minus 24 times the square root of 7. When you are multiplying or distributing like this, you have to think about these as inside numbers, outside numbers. So here, this outside number is being multiplied to this outside number to get that negative 4. This inside number is being multiplied to this inside number to get that 12. Then this outside number, this outside number is being multiplied to get negative 12. And then this inside number is being multiplied to get that 28. So outsides together, insides together. If you don't see a number, assume it's 1. Once you get here, you need to simplify using factor tree or perfect square, does not matter. And then at the very end, see if you have the same number underneath the radicand. If they're the same, combine them. If not, leave them the same. Questions about that one? If you are confused or lost, now would be the time to ask, not sit in silence. Ava, did you have a question?
How did you get negative 8 at 4 and...
Oh, because they didn't put this part. This should be 2, and this should be 2, so they multiplied negative 4 and 2, and negative 12 and 2. Lily?
How do you 7?
4 times 7 gives us 28. So that's where that 7 came from. There are questions on that one? So I'm going to rewrite it over here. Give me 2 factors of 12. Anyone? 4 and 3. So that would be 2 and 2. And then give me 2 factors of 28. 7 and 4. So that would be, again, 2 and 2. Your pairs of 2's would come out, leaving whatever is left. I'm writing all over the place, sorry. So negative 4 times 2, negative 12 times 2, and then we get that same answer. Other questions on that one? Quick check problems. And if some of you didn't get to these because you were focused on that one, that's okay. For number 2, you are, that's not what I told you to do, 3, sorry. For number 3, the overall operation you're adding, but we can't add them together if they're not the same. So we have to simplify these first. Anyone want to walk through their process and answer for that one? If not, let's say we do perfect square for both. Highest perfect square we can divide by 8 would be 4. As we're practicing these and questions on the review, try to do this without your calculator because your quiz won't be calculator. And then your x's, you can either do factor tree or the rule, does not matter. If you're doing the factor tree, you would multiply x 3 times. There's only one pair. One would stay in. So this would be x with the square root of x. And then we could do the same thing to the other one. For 18, we'd have the square root of 9 and the square root of 2, which would break down to 3 and root 2. The x's would be the same, where we have one pair of x's that come out and one that stays. And then anything on the outside we would bring to the front, multiply together. Anything on the inside we would keep inside and multiply together. So here we have 10. I forgot to multiply this by 3. My bad. Then this would be times, sorry, those are two different things. Times x times 2 times the square root of 2x. Then we are adding 9x times the square root of 2x. Then, once everything is simplified, look and see, do you have the same radicand, the number underneath the radical, or number and variable, which we do. They're exactly the same. But now we also have variables. We have to have the same variables, same number of exponents in order to combine them. We do, so we can combine these to get 19. So that would be your final answer for that one. Do we have any questions, concerns? We got lost at some point. We want to clarify anything. Now would be the time to ask.
Two x's inside of the room.
So you're saying this x and this x?
No, just one. Two x's.
Here.
To add them together.
No. So think about that like when we're adding x's in general, we don't tack on another x to it. It's just like 3x plus 5x is just 8x. The x is just there. Think about this radical as it's just there. Or like with fractions, we only add the numerators and the denominator stays. This would be like our denominator. It would just stay. We just tack it along. It's like the little brother you don't want that just tags along. So we would not actually add them. The only time the insides change is if we're multiplying. Does that answer your question? Other questions on 3 before we do 4? I don't know if we have time for that right now. Sure. Okay. 4 is asking for area. Area is multiplying length times width. So you would be multiplying 3 root 6 and 4 root 15. Insides together, outsides together. 3 times 4 would give us 12. 6 times 15 would give us 90. And then simplify. We're using perfect squares. We can do 9 and 10. The square root of 9 is 3. And we're multiplying that to 12. So our final answer would be what? 36. Okay. Before we go off to lunch, do we have any questions about that? Lily.
So if we ask like on the other part.
Ladies, you might have the same question. Listen.
For these square roots, like the 2's, for this one, then we have to, like add it together or multiply it to get 90.
Mm-hmm.
If it didn't have an x, would we have
Say that question one more time. I heard part of
if
it.
there was x's, would we have to do something else?
Yes. So if it had x's like inside, outside, whatever. If it had inside x's, we would also need to simplify the x's. If they were outside, we would need to either combine them or they would just stay. That would become. Right. When we get back from lunch, if you have any other questions, we'll go over that. Okay. And then what questions do you have on this first page? Do you want to see? You want to go over? Maybe you've tried, you're not sure about. You're not sure where to start, anything like that. Nature. Say that part again. Number 3. Alright, for number 3, we need to simplify this, so you can use your perfect square or factor tree method, does not matter. Again, as you're practicing this, try to practice it without your calculator, because you won't have your calculator. Or if you aren't good with your perfect squares, think about factor tree. You can always divide it by 2 because it's even. If you want to try other factors, you can do that. Give me 2 factors of 108. 2 and 64. 54. Okay. Give me 2 factors of 54. 9 and 6. And then we have 3 and 3, and 3 and 2. We have 1 pair of 3s and 1 pair of 2s that are both going to come out and multiply to the 2 that is already there. 2 times 2 times 3. And what is left on the inside is this lonely 3. And then for your variables, again, you can use factor tree. I'm not going to do that because there's a bunch, but you could do that, find your pairs, or do the rule. 2 goes into 9 how many times? 4. So that would be x to the 4th with how much left over? 1. And then 2 goes into 2 how many times? 1. 2 goes into 14 how many times? 7. With nothing left over. So I'm going to rewrite those up at the top where the rest of that is. We have times x to the 4th times the square root of x times y times c to the 7th. I know those kind of all mixed together. I'm going to rewrite it. So we need to simplify, put all the numbers together, everything that's outside together. So we have 2 times 2 times 3, which gives us 12. On the outside, we have x to the 4th, y, and z to the 7th. So all of those will go next to one another. On the inside, we have 3 and x. So 12, x to the 4th, y, z to the 7th times the square root of 3x would be our final answer. Questions on that? The process? Have we got the answer? Anything like that? Do you need another one of these, or do you have it? Which one? Yes, you have it. Okay. Any other questions on this first page? Okay. 11. Lily, which one are you going to say? Okay, so we'll come back into 11 after we do 10. For number 10, we are adding and subtracting. Can we add and subtract these radicals as is? No, they're not the same. So we have to see if we can simplify. Can we simplify the square root of 5? No. So we can move on to 125. Let's do perfect square for this one. We'll do factor tree for 45. Think about your perfect squares. What is the highest perfect square we can divide 125 by? 25 and 5. Square root of 25 is 5. So I'm going to rewrite this one. This would just get brought up, down, whatever. 3 times the square root of 5 plus the 7 that was already there times the 5 we brought out and the square root of 5. Then for 45, I'm going going to simplify everything at the end. Give me two factors of 45. 9 and 5. So we have 3 and 5. The only pair would be our 3's. This already has a negative 2, so that would come first. We're multiplying it by the pair of 3's. And on the inside, we have 5. So we need to multiply everything and then see if we have like terms that we can simplify. 3 times the square root of 5 plus 35 times the square root of 5 minus 6 times the square root of 5. Combine your like terms. What would you get? Do you have the answer? Go. 32 times the square root of 5 should be your final answer, because all of these are like terms. They all have the same radicand, so you can add the number in front for all of them, or subtract one of them. But do we have any questions about any of that process, how we got the answer, anything like that? If you're confused about anything, now would be a time to ask those questions. Okay. For 11, we are multiplying. So when you are multiplying insides together, outsides together, here there isn't an outside, assume it to be 1. So you'd be multiplying 5 and 1. And on the insides, you'd be multiplying 6 and 27. 6 and 20 is 120, 6 and 7 is 42. I feel like that's right.
Yeah, you're right.
So now we can either use perfect square or factor tree. If we're using factor tree, it can be divided by 2 at the very least. You can find other things. Give me 2 factors of 162. Lene.
I have a question for the last problem. What was the answer?
32 times the square root of 5. Give me 2 factors of 162. 2 and what? 28. 2 and 28. Say that again. 81 and 2. Or if you're using perfect square, that would work. Also. 2 factors of 81. Easy.
900.
I know you said that too. Okay, and then we have 3 and 3 and 3 and 3. So we have 2 groups of 3s that get to come out. On the outside, we would have 5 times our 3 times our 3. On the inside, we have this lonely 2. Multiply that. Tell me what your final answer would be. Hannah. Oh, I thought that was 5 in my head. Yeah, 45. So 45 times the square root of 2 should be your final answer. Alright, any others on this first page? Any others we want to see, go over, have questions about before we move on? Any others? You want to see, go over, have questions about? Lily? 2, and then make sure I didn't see that. But which one of you will ask us?
Should I ask with the Y, Y to the 1 first part? Why would that be in the right?
Because it was y squared, and 2 goes into 2 one time. So the 1 came out, but it was originally 2. If it was originally 1, it would stay, yes. Okay, for number 2, we are simplifying 44. Let's do this perfect squares. Think about the highest perfect square we can divide 44 by. Yeah, here's your hand raise. 4. So 4 and 11. So this will give us 2 with our negative times the square root of 11. I'm going to do the variables like this in the other way. So I'm going to write out 7 A's. It's not that many. And I would find my pairs of A's. So that would give me 3 pairs of A's with 1 left over. Lily?
If you did the square root, would it be a to the 3rd power times the square root of a?
A to the 3rd times the square root of a, yes. And then 2 goes into 16 how many times? 8. So you may want to mix it up like that, like do the rule for the bigger numbers, do the pairs for smaller numbers, or both. It does not matter. Okay, so things on the outside would be -2, your 3 A's, and b to the 8th. We would combine those to be a to the 3rd. -2, a to the 3rd, b to the 8th. Inside we'd have 11 and a. So -2, a to the 3rd, b to the 8th, times the square root of 11a. Lily?
I did -2.
There was already a negative outside, so I just brought that down. Other questions on that one? Process, answer, anything? Other questions on this page? Go ahead, Kristen. Say that again. For this one? Yeah, this. Okay. Other questions on this page? I'm gonna, 15, 13. Okay. And then I'm going to skip the next page after this. Here, if we are multiplying, we don't have outside things, so we are only multiplying inside things. So 5 and 8 would become 40. If you're multiplying variables, the exponents, you just add them. What is the highest perfect square we can divide 40 by? Christian?
10 and 4.
10 and 4. Where 4 is your perfect square. And then you can either draw out your x's or do 2 goes into 5 how many times? Either or. But how many pairs would we have? 2. With 1 left over. So on the outside we have 2x squared. On the inside we have 10x. Questions about that one? Look at, your numbers are different than my numbers, but this is like on the, not the next page, the like last page. If your numbers are like 13 through 16 or something like that, sure. But when you reference the numbers, just say mine, 14, 15, 16, 17. Of those four, which ones do we want to see, go over, have questions about? Nature.
Mine for
Yeah, I was gonna say 15.
15. Okay. So for this, 15, and then if we have others, we'll do that. We're multiplying inside things together, outside things together. So outside together, and then inside things together. And then for this one, same thing. Outside things together, and then inside things together. So on the outside, we have 3 times 5. On the inside, we have 2 times 10. On the outside, we have 3 times -2. On the inside, we have 2 times 6. Before we continue, do we have any questions so far? If doing the, I would say errors, but that's kind of what these are. If this, seeing where you're multiplying helps you, do that. Okay. Now our operation is subtraction. We cannot subtract these two because they're not like terms. So we can simplify. So if we're doing factor tree, this would be 4 and 5, and 2 and 2, and 4 and 3, and 2 and 2. So we have a pair of 2's that come out for both. For this one, we have 15 times 2. Inside, we still have the radical 5. The other one, we have -6 times 2 times radical 3. Multiply and see if you can simplify. What would our final answer be? Thirty times the square root of 5 minus 12 times the square root of 3. We cannot combine those. Questions about that, how we got it, the process, the answer, anything like that? You got lost anywhere? That would be a good time to ask questions. Any others in that section? Cameron. This one? Okay. Okay, same thing. But here you have an outside thing that would be 1, so you're multiplying outside things together and inside things together. For this one, you don't have an inside, so the only thing you're multiplying is the outside. So this will look like 1 times 7, 6 times 3 on the inside, and then 1 times 6. But even though we don't have an inside piece, we need to still include this because they were connected. So we would just bring it along. Questions so far before we continue? We can simplify the square root of 18. So if I'm doing perfect squares, we have 9 and 2. So 3 and 2. 3 times the square root of 2. Multiply the 3 by 7. So you have 21 times the square root of 2 plus 6 times the square root of 6. Plus. Those would not be able to simplify more or combine, so that would be your answer. Other questions in this section? Or questions on that one?
Can you do the 16 verse 15?
Yes. We're not gonna do this one. It's not gonna be on the quiz or the test anyway. So we'll do this one. This would be similar, but for 16, so I'm gonna talk through what you're doing and then rewrite it. We're taking this and multiplying it to the first term in the second set of parentheses and the second term in the second set of parentheses, but also taking this second term in the first set of parentheses and multiplying it to those two, which is why we rewrote it to make it look a little better. So it would be 5 times this set of parentheses, and then this second term times that same set of parentheses. Then we can distribute. So the 5 and the 4 would just be numbers multiplied together. The 5 times the square root of 2 would be really multiplying the 5 times the negative 1, and the square root of 2 would be at the end. So negative 5 times the square root of 2, 7, not 2. And then we could do the next 2. Here you're multiplying the outsides together. You don't have an inside, but you would just bring this down. So plus 8 times the square root of 7. And then the last one, you would again multiply your outsides together, the 2 and the 1, the negative 1. But you do have insides you would multiply together. So those would both be underneath the square root. 7 times 7. Do we have any questions so far before we continue? On which part? Okay, so we rewrote this. Did that part make sense? Okay, so we're taking the first term, multiplying it to the second set of parentheses. We're just rewriting it. And then taking this term and multiplying it to those same parentheses. We just rewrote it. That's all we did in that step. Okay. When we multiply this, did that make sense? 5 times 4 is 20. Okay. 5 times 1 is negative 5. And you just have to bring that down. Okay. Same thing here. 2 times 4 is 8. And you just bring this down. And then here you're multiplying the outsides, 2 and negative 1 to get negative 2. But here we have 2 insides. Those get multiplied on the inside. Does that part make sense? Which part?
I get all of it. Like I don't moving the first number.
So if the moving is confusing, I would say just try to get it in your head that you're just rewriting. Does the multiplication part confuse you? That's what I'm trying to get at. Okay. So the moving part, you're just rewriting. Everything else is just multiplying. If we had 2 sets of parentheses like this, you're taking this first term and multiplying it to this set of parentheses. And then you're taking this and multiplying it to those same parentheses. You're just rewriting it. We haven't talked about actually why we're doing this, but that'll make sense when we do polynomials. Yes.
Questions like 16 dealing with this.
There will be a distributing problem on the quiz. I don't think it's like this. I can't say for certain about the test because I don't remember. But I'll look. Remind me. And I'll look. Okay. We need to finish this so that you guys can do your quiz. Square root of 49 can be simplified. That's just 7. We have negative 2 times 7. And everything else gets brought down. Of these, which ones can we combine? Wait, I heard you said 7, but the square root of 7, yes. So if we combine those, what would that give us? Yeah. 3, positive 3, times the square root of 7. Can we combine anything else?
$14
14 and 20, the negative 14 and the 20, yes. 6 plus 3 times the square root of 7, we cannot combine those two, they're not like terms, put the number in front, that would be your answer. Yes.
Do you have to put the number instead?
Yeah, so if we don't put the number in front and then we end up like this, you may either end up putting it underneath the square root or combining it when you shouldn't. So if it's out front, we know that those two things aren't the same. They don't have a radical. Normally when you see it, it'll be number, then radical. Right? Any other questions on this one? Or any other specific general questions at all? Okay. So at this time, go ahead and put your notes away. I would say put your calculators up, that way you're not tempted to use them.